Good morning, or whatever it is, wherever you are. This one's actually just about to wrap up. Boom. Alright, so I've actually had a couple, I had one, when I was trying to deploy the LifeLog, or the family tree server, I was like testing it, and it's like, timeout? It was actually, for a little bit, it was like taking like 30, Heroku was like timing out at 30 seconds, and it was taking quite a while. Then while I was working on it, it just started happening in the like 2.5 seconds again. I also saw, apparently there's a 5-second timeout in the Rails app on database queries, which is something I'd be less surprised if it took twice as long as it taking impossible times. But let's see, is it just that? Well, we're going at it through Rails. Probably just straight up SQL would have the same issue. DB lives. No. SQL did it like we're currently using iLike. Now this is not going to, by default, give me times. Oh, no, we do have the logger on. Okay, so the first one took 12 seconds. And then after it's loaded in. Okay, so that tells us something about how much worse that can go in a unloaded scenario or a cold scenario. Now, is that per query or is that just for the index? Oh, there's more of those. We do need the first time. Nope, okay. So now that the index is loaded, it's doing that okay. Would it be useful? Well, I don't know if we always get timing if we go to Postgres directly. No, I know I've been doing explain analyze. we do select star, I'm assuming that's the operator. All right. We've got a cost, but not a time. Hey, Thuddy Prime, how's it going? All right, copyright. Edit query buffer. Informational. List. Toggle timing of commands. And okay, so that is very representative of what we were seeing on the Ruby side as well. And I'm just curious, how does it compare to this? Substantially the same. Oh. Cool. And I honestly wasn't even thinking about the 3 part, but managed to pull it off anyway. All right. So I guess I can actually, well, I'd have to look up the straight up Postgres syntax, and then we'll have to translate it back into Ruby land if we find one that works. All right, so we want to do I want to be careful with it. It's not really fun. I don't need full text search. Fast, it's a substring. It's left aligned right now. Won't be updated often. That's a more complicated pattern than we need. Full text indexing. So I haven't done the indexing yet. Text pattern ops. Now you see, I tried that, and it didn't really help me. External search and indexing. Substring index. If you're always looking for a certain number of characters. Oh, I tried that one too. All right, create index, sure. On lives, name. Of course, I was doing it through Ruby at the time. Yeah, so that's not appreciably different. All right, so is it drop index? Okay. Operator classes and operator families. Well, there's varchar pattern ops. PG trigram. Oh, and this is a module. Which you might have to enable. Standard. TRGM. And properly speaking, it is PG trigram. Extensions. Supported extensions. Well, I'm gonna have to get my I'm gonna have to add PSQL to the path and then like reboot to make that actually available to shells. So it's not a good streaming solution. Similarity of alphanumeric strings. Yeah, anything I don't need. It hasn't asked me to update. I haven't really been paying attention to the beta channel lately. Oh yeah, I've not tried it on the MacBook. I know that well, technically, I mean it's not even a MacBook, but I know that it was that recently it has been quite problem. It has encoding has not been good. It really struggles to keep up, and yeah, the Mac version is not well supported from what I've heard. And it's definitely not my area of expertise. Plus, I mean, I've just been using NDI just to do just screen capture there, and then do the encoding on this computer, which only works when I'm at home. And these are the other things I saw. All right, so there's Trigram, which is like, well, I mean, for a for an open source project like that, I mean, even full time is pretty good. All right, so that's an optional module. Inferior to the standard, except for multi-column indices. It can't be used, and exclusion constraints. Except for developing new GIN operator classes, a multi-column GIN index. Huh. Wait, so is this an extension? Also an extension has to be enabled? They don't indicate it here. Exclusion constraint. Exclude. Oh, geez. Elasticsearch. Well, Elasticsearch is its own animal, right? Now, I have toyed with the idea of I thought, No, wait, Amazon. I mean, I'm operating in a Ruby context. I was just trying to kind of figure this out at the database level. So there's Amazon Elasticsearch, and apparently there's elastic.co. And Amazon just implements it. Oh, okay. But that's the engine. And this is probably the easier one to... Firefox used to be able to adapt to theme changes. Doesn't do so well anymore. Oh, and, well, I am going to have to... Because they reset my settings sometime. No, Amazon doesn't even show up. Open source software. Yeah, so one of the things I've thought about doing is Amazon has like a distributed SQL database, which in theory scales based on the number of requests. So that would be one option, but like Amazon has so many products that are very, 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 very configurable. So it's a trial to get anything set up. And if they do give you an easy way, it's like this pre-configured projects that are doing all this complicated stuff you don't understand. And I like to understand things. So actually, it's definitely not a plug and play thing. Oh, okay. Well, then I have to spin it up somewhere else. Although they might have better color management. Ah, okay. Simple and Elasticsearch focusing. Now, how much do they? I mean, I guess I don't know enough about what this thing does. All right, so they're the hosting. Still $9 a month. Roku Postgres. All right, so the current database is 2.7 gigabytes. So we definitely could not host the entire thing here. Okay. Just the search index, okay. Storage, so we'd have to know what the index size is. And this only goes up to there. And we still have to know how to do that. Oh, model. So you're probably based on... Why'd they downcase everything? Yeah, so the easy path here is all based on active record stuff. So I'd really have to drop down to the base version here. That's Ruby Rails. Well, I mean, this is model and this is Rails, so... I have to do a lot of stuff. Ah. Elasticsearch Ruby low-level communication. Client new. And then we're into active model, active record. So you'd have to get into the further detail of this. So, I don't know. I mean, if the extensions are available. Well, okay, so maybe using these functions is a bit harder. But I did find some references to these other indexes. For these, although gist required you to use a special function. Create index on lives. I don't know. I'd have to go look that up. Type character varying has no default operator class for access method gin. Oh, for the data types. Well, char varchar. Okay, well, this is low-level stuff. And this is not the level of documentation we want. Two separate indexes. Oh, there's an extension is btreegin that expends its use. Likely use two indexes. Operator class. Oh, but these are two different fields. That was on a JSON B versus that as a regular index. I think we saw it in the extension list. So we have to create extension. Let's see. Documentation. And it's not a acronym. Cardinality, yeah. It's probably like generalized index network or something. Nope, that didn't help at all. Is that drop extension? Okay. Yeah, so I ran across something the other day that said those were better. Okay, so we've got all the Elasticsearch stuff. So Trigram Indexes, which were also kind of stopped by B-tree Gist, where you had to use unless it's instead of B-tree. Oh, this doesn't have the special usage syntax. And I said these are typically worse. Now you are also an extension? Oh, they're using it specifically for exclusion constraint. Okay. They're saying a given cage cannot have unequal items, I guess? So there is always full text indexing if we really want to nuke it. Text pattern ops we tried. This will be another extension. This also seemed a little bit overkill. Does this need a particular operator, though? Index part. Similarity searching. Okay, so this does require particular operators. Using conjunction with full text index. Yeah, this isn't quite what we need. Well, it's definitely taking its time to build it. All right. So if we did go full text indexing, tables and indexes. And that uses again. And maybe it's more efficient in the TS vector. The two argument. Two argument, only text search functions that specifies a configuration. Default text search config. It's really thinking about that. Separate column. Because the configuration is the point of creation. Pressed enter, right? Okay. And it made no appreciable difference. All right, so we were looking at trigram. Which I'm not quite this is really a word similarity thing. Which if you wanted to do, I'm not actually sure would be good for partial word matches. So you're probably an extension, aren't you? Provides gist and gin operator classes. So does that mean we don't need the B-tree version? Yep. Create extension. That are sufficiently similar. Oh. Be implemented officially by gist, but not gin. Well, that's something we might have to try. All right, so we were doing this. So we're selecting the similarity, but I guess where... That's faster. Oh, but that's too many rows. Okay, so exact match is 1. It actually gets a misspelling, which is nice. So I'm actually curious, what is... Okay, it somehow matches. I guess it's greater than 0, effectively. Huh. But that's an exact match. So that's faster. That's better results. There's this version. which they say performs better with the other index. Oh, so distance is kind of the opposite operator, and yeah, that's pretty slow. In fact, that seems like pretty much a straight up inversion. So we would want to test, create index. Nope. I can also use an index on the T column for word similarity. And all these operators. For which there is a continuous extent in the corresponding order trigram. Oh, also support the like and I like. Those gist indexes do take a while to build. Text search. So this is something you can add the text search as well. So I guess TS vector and TS query are just kind of built in. Well, no, because we're down. Well, maybe it's just built in. All right, so we were testing with this. Well, that's still a second. It's better than we were doing, but still a second. What about... Okay, oh, well the count got faster. Well, that's tolerably fast. And it might even... support double-ended search. How does that fare in... Okay, a little bit slower. But it would be possible to find everybody in a family, for instance. Although it mostly seems to be returning first names. All right. So that is an option. So just for comparison, all right, so that's for multi-field search, which we don't really need. So we've got TS vector and TS query. Actually, I had a little bit of code for this. At the time, I was doing 2 documents and no index. So this is, actually, even this doesn't need to be I-like. This could be, let's just figure out the operator for lower in this case. So that's something we should probably do. Okay, so it's specifically extension fulltext search for a single field and multiple words. So what we would have to do is define the index on the name. Create index. They seem to prefer gins. Scroll too far there. Two TS. Okay. Yep. We're gonna have to, and then I'm gonna have to test how. Look at how SQL implements that very specific TS vector format. All right, for a straight up SQL query, so it's 2 TS vector at TS query. Cat star from lives. Where 2TS, and the vector is the thing we have to match. Okay, well that performs a bit better indexed. Now, but does it do prefix matching? Yeah. So this might, So this might be where the Trigram module came into combination. Parsing queries, parsing documents, dictionaries. Oh, okay. So this is... I'm going to have to figure out how to do that in... So it's possible to do prefix. I just have to figure out how to translate it into the SQL format. And that's still faster than Trigram was, although not as versatile. For instance, it did not... The Trigram found the LL version, which seemed pretty nice. Okay, so full text with an index is faster. And we're still down in the tens of milliseconds. Full text is much faster. But we're still in the very strict search territory. Okay. And we do have to do some extension stuff. SQL extensions. I think it's automatically picking that up. Extensions plugins. Oh, this is the other kind of extension, isn't it? Is that data set just files? Okay, there's nothing here called Postgres, but I know there is a Postgres extension thing. Specific support. Exclusion constraint. Turning rows. Oh, well, there's the insert on conflict thing. This doesn't have the full text search. Oh, dataset methods, okay. On PostgreSQL. Planar phrase. Terms argument is already a valid SQL expression. Returning a TS query can be used directly in the query. So that would be how you could add the stars and things. And then options, the terms argument calls terms. Columns contains all of the words and ignores search operators. Oh, what I was actually looking for was... Okay, so you're not specific to that. We would... So we're still on active record migrations right now. Enable extension. There's also just SQL. Okay. So we would enable the extension, create the index. First step, auxiliary table, containing all the words. Gen trigram ops. Huh. So actually that's interesting. If we had the really fast version, then it becomes more reasonable to do things like real-time suggestions. Well, that's once it's even started up. So this was, we were playing around with full text search, which doesn't need anything. Rails G migration. All right. Migration, add name index. Was it create extension? Enable extension. Oh. Would this properly reverse the order of operations if it auto undid it? Well, I guess we can check the undoability of it. Now we've created indexes elsewhere, right? Now this is going to require a very specific syntax. And we said that we had to use quite efficiently in GIST, but not GIN. And then they support like and I like. Although, does that get the fuzzy matching? Add index, generates, unique true, named index, specific key length, the sort order, partial index, using all right, you are B-tree GIST. That's enable extension. Using B-tree name. Specific operator class. GIST trigram ops. There we go. Using GIST. All right. Rails DB migrate. And those GIST indexes do take a while to build. Oh, that's a MySQL full text index. I was like, wait, isn't it TS query, TS vector stuff? All right, and I want to make sure that this is undoable. So we'll have to wait through that again. Okay, so it does reverse the order. All right, so that is, where were we testing? Yeah, we were testing this stuff. I just want to remind myself how, if it still did the LL thing and such. All right. Oh, that was a little bit longer now. But Oh, that's for the fuzzy matching, I do have to get into the operators. Stuff. And I don't remember to just select similarity or T% word. And I should probably just select the name here. Oh. Okay, so it's one of the other examples, because that's just... Oh, that was probably ordering by similarity. Because that's not 87 milliseconds. Do we have these? So we're testing this stuff. We were testing that one. So that was taking 10 times as long. Which makes that not an acceptable answer. What were the other options? Well, did we actually create what we wanted? Oh. I forgot to go in and drop. Probably got... Oh, but now I have to do some stuff. Well, actually, there's probably like a schema dump. Yeah. That wasn't by any chance affecting... Nope. Oh, that's different name. Index lives on name, op class. We think that should be the same. And yet, it's very much slower. Maybe it was one of the other queries that was fast enough. Nope, 10 times as long. I have no idea what happened there. But that's far less of an acceptable trade-off. All right, so we're back to full text search. So lives, name. What were we doing? And we actually had the syntax in the schema file for a little bit there. I'm going to just... So this is a 2-parameter function. Is not as arguable against your index. Exactly the expression. Huh. So what's simple versus English? There's probably a different topic for this. Tables and indexes, text search functions and operators. Config. English. What's English versus simple? Configuration setting functions? Wait, this is... Oh, this is not the up I wanted. Configurations. Doesn't tell us what the options are. Maybe throwing away non-English. Maybe it is here. Config English. List of dictionaries. Rats became rat. Oh, so actually, these are names. So we don't necessarily want to be doing those translations. Okay. So you're just using a straight up execute to get exactly that. Because we don't know quite how to do a function with an argument. Create index. I don't know what their usual pattern is. Oh, actually, the schema dump might tell me something. Schema. Their format is index blah on. And okay, so it's just a string instead of a list of columns. And then we do get the using gin. Well, as long as the information's there, it's fine. All right, so that gives us an index. These have to match. Okay. Well, and I guess I could do trigrams with this via the other system. All right, so now we have to figure out how to specify the open-ended terms in Ruby land. So this is just full text search. Full text search. There was something in. I didn't keep it up. Inclusion of any of the terms. Calls argument is already a valid SQL expression returning a TS vector. It can be used directly. The calls argument. The terms argument, which, oh, maybe they were doing some translation on that. So this would be coalesce. So it's just automatically doing the coalesce. Well, that's probably for the nulls. I mean, admittedly, I was just doing a count before. Oh, this doesn't have the index because a SQL expression returning a TS query. So we need to do the full thing. Oh, default simple. So we need to maybe not do true on this? Okay, it's definitely still slow, so we need to get this formatted right. Cast simple as reconfig. That is not the kind of query times I was hoping for. Is this... I was selecting less stuff. Or even just a count. Okay, so something in that is actually breaking. Timing? I mean, you know, we can feel it's slow. So I wonder if it has to be the cast? Because I did say the expression has to match. Okay, that's not it. Let's see, I was not doing this format of TS vector. This is even slower. I was not coalescing name. Yep. What the heck? And I don't have my scroll back to the expression I was using before. Well, it would have been select name from lives where to ts vector name to ts query and now it's taking 3 seconds. Did I like not describe table gen to ts vector simple reconfig name text. Interesting that it's text and not varchar. Those should be pretty close. So it exists. So the exact expression that is a double. Now I'm really sad about my scroll up buffer because I was getting 2 millisecond responses. All right, so I was originally basing that off of the samples, which I've moved on from. Using GIN, well, okay, I was doing English before. I don't know why simple would make that worse. If anything, I expected it to make it better, but that is a difference. To TS query. Okay, well, that's even worse now. What the heck? All right, well. Not automatically reversible. Okay, well. We do want to get that migration as unapplied. I guess this is where the actually changing to the add index form might schema would actually solve this. Add index. Lives. All right. Now, the way we did this originally, create index, test index, on table, using gin of oh, maybe it's the TS vector that has to match. Well, we already dropped it, so. Right, we did simplify that out. On gin to TS vector. And let's see if we can get back to where we were. Yep, on table. All right, maybe this is the one that has to have the matching. Okay. All right, so I can't get back to a blank line. Create index. Now what about simple? Okay, so I got my focus backwards. Now what about, do we have our original... Okay, so this thing is still messed up. So there's this. Maybe it's the coalesce. Okay, so I have to make the index on exactly what that's going to generate. Any of the calls, which implies that should be an array. Options language. To TS vector calls full text string join. Which we'd have to look up. But it's not a readily accessible public function. Okay. I think you actually do keep a history. I'm just curious. Cast simple. Yeah, it still does the coalesce. That makes no difference in that. So we need to be this exact expression. Oh, and we actually need to go back because we created that index in Postgres. So we seem to have lost one of those. And I guess this also gives us a chance to say index name on lives to be a little bit more unexpected T identifier. Okay, we haven't actually done anything with that yet. Unexpected keyword end. You probably had quotes in you. All right, Rails C. No, we're back in Postgres. That's a little bit more like it. Now, what we do is for our actual search code here. So I guess we'd want to say last word. Query.split.join .map. Really, only the last one. So it's only the last one. To get equivalent to that open-ended. I don't really know if... Oh. I wonder if I had the same... No, because even when I went back to straight up Postgres, I wasn't getting the results I wanted out of Trigram, which was very, very peculiar. All right, I think you're in 5,000. All right, that was relatively quick. And that was nice and quick. Let's see, I think I saw this one, although I was searching for a, oh, but I didn't put the limit on it. Ooh. Well, that was still half a second for 100 results. So we're not completely out of the woods. All right, so we've got our full text syntax. We've got that. Now, did I have... I might want to do this just as straight up. Where... And hopefully any hashes that are floating around are in the right format. For example, nope, wrong window. Okay, well that seemed pretty decent. Yeah, so if you can do exact match, it's fabulous. It's curious that that takes so much longer. I guess I should be looking at things like... Well, nope, that was fine. Oh. Oop, well, that still needs an and. Yeah, I'm getting this mixed up with my Postgres syntax. It's like, that's fine. Oh, that was an unlimited query. Oops. Like, wait, is I missing that there? No? Okay, well, that's still half a second. Just, it feels fast enough. Huh. Maybe it actually indexed Eve better because it's such a common term? Well, we can see if that will do the trick. hopefully that takes care of it. Index, name, search. So there are still some surprisingly slow queries. Is it the number of characters? So I did have, if you just do blank. Oh, okay, well, good thing we test these things. So the blank query no longer returns you all recent stuff. So probably we just have to check for blank. Although that raises other questions, like what if we did... Okay, well that's fine. The split takes care of it. The only real problem here right now, well, probably would also have trouble with something like that, which is not 0. If terms greater than 0 else well, no, because we'd have to because we have to care if it is an empty string. I think there is no else on this. We just don't filter. Oh, terms.length. Really, could do that. Yep. Lot of die babies. Okay. Oh, is that a problem? No. Huh. Well, okay, so now I'm curious. dblives.order. Oh, actually, the most recent burst may not have been named yet. We want the most recent, or number of names among recently named. So with some 623. I think we have this expression in U. SQL desk, birth time. Okay, yeah, there was just some periods of spam in there. Or maybe even... No, we shouldn't have had deaths only. Huh. But anyway, let's do... where... Not... Name nil... I was curious if it has something to do with length. Maybe it does. So Eve Collin was okay. But that is very not okay. Wait. Why? I mean, okay, I've got other conditions. So the limit actually makes that way worse. How did you do... Oh, well, that's sort of... You can see some formatting, but it's still terrible. Oh, no, it's just... Okay. No. Explain, analyze. Seek scan on lives. Filter. Rows removed by filter. Execution time. So it had to do a seek scan index cond. Huh. Recheck con. Parallel index scan. Parallel bitmap heap scan. So would I be better off doing a subquery? How would I do that? How would I do that in SQL? There are no results in a limit. Seven seconds. By scanning the rows, it's not close to the beginning. Removing the index. Cannot use the... Huh. So we need to know how to do a subquery. Well, okay, there's two things here. First of all, we had an actual error with blank strings, which I think we fixed. Yep, and this is, oh, depending on how close it is to the front of the table. Yeah, so we fixed that. There's a lot of nameless people there. Second problem is we've discovered that certain queries take extremely long, which will be too long, and we will get cut off. Oh, subselects as scalar values. Subselect. Test for exclusion and exclusion in a subselect. So for that condition, we actually have to kind of start over. Result.where I guess for this we could do the default ID because it's a single query thing. We don't have to worry about inconsistency. Dot select ID. Well, that doesn't actually help. Even though the select query is theoretically fast, it actually made it worse. Oh, no, we're in Ruby. Yeah, but should have times. So that's fast. Oh, I wonder if the limit's getting passed through. Oh, I don't need the puts anymore. Although it actually does end up formatting things a little bit nicer in many cases. Okay, so that's still fast. That's still slow. DB lives. Oh, I don't have an index and ID, I bet. Yeah, maybe Rails does one by default. No. Well, that wasn't several seconds, that's for sure. It was still one. That cuts it down a little bit. Ooh. Yeah. There's your 7 seconds. Well, is this a case where we do filter that pluck ID Oh, that's terrible. Now, the problem with that is, let's pretend well, blank will be nothing, but let's pretend we do something with many, 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 many more results. This probably would be improved by a limit because it hits a result early. This also makes me, well, I'd have to figure out what the heck went wrong with trigrams. Can we count these easily? Well, it's 1 second just to count them. So this is really fast for good matches and really slow for bad matches. What if and we're back to our 2 seconds. So we could maybe find a number of characters where it starts to matter one versus the other, but that 2 seconds is still going to be too slow. Because we know we're getting timeouts at 2.5 seconds. Does limit help with these? Okay, limit helps with those, though. So if we can figure out... So a single character is not great. And that's not really going to change it much because of all the eaves. Although even at 2 characters, we're sort of tolerable, but... that's going to take a little bit longer. Oh wait, that's doing a select star? Okay, so when I do plucks, I actually need to specify the select. Which actually does help considerably. So at a 2-character term, well, actually, that probably wouldn't do anything at all, because there'd be no results. Yeah, so you can't do partial. And then that should be plenty specific. And that's actually, so, and then we have very long specific queries. The limit makes it worse. Yeah, so even though I can't use 100, I actually have to not do that. Oh, but with, well, so for very short terms, oh, no, wait a minute. For very short terms, you can do this directly. It's only, well, so I've been looking at long terms. Really long terms are terms that are not found. Oh. Yeah, so you can't, it's not just length. So we could burn some time on that. Okay, so if it's a few number of, if it's like one character, it can be extremely slow. Especially if it's a common character. But if in that case, then the actual results are fast. Yeah, so I don't have a good rule to decide between ways of approaching this. That's a non sequitur. Is that a Markov chain? All right, so we're saying that if it's a very small query, then this, we can just use this. If it's a very long, well, it's really if it's a very common query. If it's a very small query, it may have many results, although it's not guaranteed to have many results. You can count the small results, but if it's a very large query, the count is expensive. Are running most expensive. Yeah, I want to know if there's a way to tell if a query is going to be very expensive before executing it. Because directly executing the filter on long terms. Now, is this specifically at the open-ended side of this? Oh, it is. So do we only apply that below a certain number of characters? So what I actually want here is the time, not the results. Oh, but limit 1 is fine. I must find the first one faster. I just have to keep searching the entire table. How about all, and then we do an array operation on it. And really, I mean, we could do something even simpler. Now, does this change much with the length of the string? Ooh. Maybe it's this for just this particular. It's this particular character sequence. So it's not even as much length of string. Well, that was a little bit better. Okay, so it's not length of string. Oh, until you get down to 3. Do I want to demand exact strings, though? Oh, we probably got down to a point where we found other names sooner. So I have no way to know whether this form of the query is going to be expensive. We can make this query faster by doing not a limit to a ID list and then passing that back to the database. But that becomes unreasonable if we have an especially large number of results. I almost want to look back at trigrams. Because at least, well, I didn't really fully test that out in different scenarios, but at least the worst case, or at least the cases I was looking at, were not substantially worse. Create index. On using, and this is the one that was better with Gist. Oh, Well, supposedly better. All right, so, and then the queries for this. Name from lives where. So we were initially testing with. Okay, so this gives us lots and lots of matches. So we really do want. But yeah, maybe I need to maybe it's something about these particular queries. So our first query. We're back to 800 milliseconds, but at least it's consistent. All right, so. Still a lot slower than I'd like. How does it respond to limit? Slightly improved by limit. See, well, I guess, With this, I am going to have to do. Yeah, so what I was doing before was order by birth time. I'm trying to smaller limit for this. Ooh. That's actually worse than the calculated value. Yeah, so now you start getting like weird matching scores thing. And it was very, very slow. Okay, it's got an index. Filter by that, index scan backwards. Rows removed by filter. Now I think Wow, that wasn't explained. That doing these out of order, well, doing it in order helps. But the order is actually pretty significant there, surprisingly. I guess because it's already calculating that, it's not like an extra thing to do. That is interesting that the order actually slows it down. But this is like too loose. You really would have to include an order by similarity to get useful results. Well, I mean, I guess it would be order by okay. But man, if you were just trying to find, well, if you're trying to find worth be worth. Which would have a different similarity function. Yeah. So we have a very consistent query time with that. It's better than the 2.5 seconds. All right, so we've got some other methods, a variant of the query, which is distance. And really, I kind of like having a few extra available. There's no where condition here. It's just straight up order. As dist. Oh, we didn't remove where. Okay, so that's slow. You can also use an index on the column. So this is word similarity. Order by... There's a whole other where here. Let's just look up these operators. Oh. That is not as loose. And that does give you like the other formats of that, but wow, it's I guess Farnsworth is a case of few results. So we've got exact match. So this actually seems like the kind of operator we want. So the Eve columns are a bit far out there, but oh, and there's enough of them that we're not even getting into fuzzy matches, which also kind of works. Strict, which is this. You might want the stricter, speaking of strict, stricter term. So I don't know what that means. Well, no, I guess there was like Colorado and stuff farther down. Yeah, so that's... And then with operators, and we can do this. That doesn't give you the similarity bar, though. Depend on relative character performance, which is discussed elsewhere. Full text search integration. All right, returns true if arguments have a similarity that's greater than the current similarity threshold by similarity threshold. Current word similarity threshold. Matches word boundaries and is similarity. So I guess the problem with word boundaries would be the prefix problem. Well, it matches a word boundary versus okay. But, the flip side of this is you wouldn't even see that double letter misspelling. In this version. Now, it was a 0.7, so that's actually part of a function of the cutoff. Current strict word similarity threshold. Distance between the arguments. Word similarity. Index support. So, and this is an interesting trade-off because we've got far more, well, I've yet to find something that is just like really, really bad in the same way that the full text search could get really, really bad. It's just kind of consistently slow. We know that this gets off into like worths and things. Yeah, that might be a little bit too sloppy. And did this find... And actually this, which one are we on? Yeah, word similarity actually finds a bunch of similar things, but puts the exact matches up at the top. Okay, so we're... so I don't need this as a column in my results. Nice as it is to have. What we really need is... shouldn't we do have to repeat these? Oh, I didn't do that. Wait. Wait, that got my Eve columns first. Oh, but it's ordered by similarity. Wait, what? Oh, my arguments are backwards. Oops. Okay. I still wish I knew why I was originally getting like 87 milliseconds for this. Actually, it doesn't help me. So we have to do custom operators and custom functions. Oh, and we have to change our order by condition. db lives dot order birth time dot order. Okay, doing another order by clause just wipes out the previous one. So we need to do custom functions, SQL function, and operator. Identity operator, inversion operator, inequality operator. Uh-oh. Bitwise mathematical operator. Complex expression. Custom Ruby operator. I might just have to do a SQL fragment to do those things. Operators. Technically, that's an extension of the similarity value. Current similarity threshold. But didn't you have your own threshold? All right. DB lives. Select name, order by function. Was there an appreciable improvement doing filtering? Order by SQL.function Heard similarity. And it was the search term and the column. This needs to be and actually also you are five seconds. Pardon? Okay, this is not conditional. We don't demand there be any similarity in the data set. Maybe this one's supposed to be ascending? No, these seem to be the least similar. So we need a where in here. So one way to do this, I don't think where order can use result columns like the calculated select. I don't think where can. So I'd have to repeat the similarity expression if I wanted to use function. And I'd have to know what our similarity limit is. All right, so what is our, oh, like, you can just use SQL, db fetch, database literal. Column string. Is that lit or literal? It's going to return that as a oh, I think it's supposed to be like db lives, I guess. But that's a string. function inequality yeah, there doesn't seem to be any yeah, it's a little bit too much translation. In a database, there's the raw version. Raw SQL, okay, so that's SQL.lit. And I don't have any way to put that in as just an operator in an expression. So we pretty much have to do the full thing. So this is going to a variable value. Well, that would be like a okay, literal there. I don't know if you support holes. Okay. Yes, you can do question mark, SQL lit, question mark. SQL lit, where name, oh, what was the order on that? String less than placeholder literal string args. All right, so DB lives. Order by, not necessarily where you'd put it. Where SQL.lit squeal. Where are ye? Eve column. And that's, well, okay, I guess for a similar query that was comparable. And now we have the problem of this console will not let me get this entire expression. Oh, well, I need to capture this. We also have to do migration stuff. All right, so there is the where expression. Oh, and suddenly we're way past it. There is the order expression. And actually the rest of this we don't really care about. Okay, so limit 10. All right, drop index test index. We need to Rails DB rollback. Add index. This might be easier to do in line. Shoot, what was that syntax? Enable extension. PG Trigram. And index. I think there was some special syntax for this. So using gist, index names on lives. So that'll wrap the gist around it. Name gist trigram ops. Those gist indexes, though. All right, so you would do result equals result dot. And query. Actually, is there a operator to like prefix ordering? Oh, apparently dot reverse is the easier way to do that. Data set. Order prepend. Okay, so that was, yeah, we got our 0.7 seconds, but it's kind of reasonable. Whereas the other one was like 7 seconds. And now we start getting similar names. If this does a blank string, oh. So that's no longer a means to get all recent results. Well, I should probably continue to have a how would you I guess we're still in a Rails context, so I think there's present. Chomp chop. Length of 0 only. Well, how does that affect you? Yeah. Turns a new string with the given record separator. The last character removed. I think trim. No. Strip. Leading and trailing white space removed. Query dots and not query dot strip dot empty. Just a bunch of recent stuff. Okay. Change to Trigram Index. Consistently slow, but doesn't seem to explode. All right, so that is all back end. So if we update the service, we will hopefully see fewer timeouts. And we'll have to see if we can actually migrate the extension on Heroku. But that will be in a bit. Meanwhile, I want to have lunch, particularly because I have to leave early today. So I will see if I actually have time to doing Factoria this afternoon. So meanwhile, thanks for watching. Thanks to everybody who hosted me. We have any other code going on? Let's see. So we've got 3D front-end stuff. We've got procedural world gen. Game. And this is about when I tend to be on. That's probably going to be over soon. All right, well, don't see anything super database related. So if you're looking for someplace cool to hang out, looks like Fifth Function is working on his JavaScript game engine. If you're looking for someplace cool to hang out, that's someplace cool to hang out. Thanks for hanging out with me. Goodbye, and until next time.